Hi everyone, today we're going to be reviewing simplifying algebraic expressions, and we're going to begin by identifying the parts of the expression, and then we're going to go ahead and move on by actually simplifying the expression. So one of the things that we need to remember in order to be able to identify the number of terms in an expression, and we're going to look at this one right here, is we need to remember that it is separated by either a plus sign in front of the number, or sometimes you might not see it if it's a first number, or a minus sign. And that's going to determine how many terms you have in this expression. So if you look at the first one here, we can go ahead and see that we have 1, 2, 3, and 4. So there are 4 terms in this expression. And the terms are 7x, -5, x is another term, and -3x. Now, which terms are alike? Terms that are alike are terms that carry the same variable. So I can see that there's 3 terms that are alike here. We're going to go ahead and take the like terms. So my like terms are 7x, x, and -3x. Once again, they are alike, like terms, because they carry the same variable. And before we continue, let's go ahead and review a little bit on coefficient. Remember that this variable x here, its coefficient, it's understood to be 1. So if you ever see a variable by itself, you know the coefficient is going to be 1. It's understood it's 1. So the coefficients, let's go ahead and identify those. For 7x, it's going to be 7. For x, and of course a coefficient is the number in front of the variable. So since that -5 is a constant, it doesn't have a variable behind it, there is no coefficient here. So for x, the coefficient would be 1. For -3x, the coefficient is just -3. And the only constant here is -5. The number without the variable is called a constant. Like terms can also contain power. So you can see here the example of 3x squared or 2x squared. They are like terms as well because, yes, they besides the same variable x, they also carry the same power. So that was a little bit of a review with the parts of an expression. Now let's go ahead and move on to some examples. Some examples here that we have are simplifying the expression. So we're looking at 5x plus 3x. In order for us to simplify the expression, we must have no parentheses, and all your like terms must be either added or subtracted. In this case, we're going to be adding these like terms. We know they are alike because they carry the same variables. So my answer here is 8x. Over here on this one, our like terms are going to be -2m. So I'm going to go ahead and circle -2m and 6m. And I'm going to go ahead and just underline my 5 and my -3 because those are also like terms, but they're constant. So now I can go ahead and solve the problem. So -2m plus 6m. Let me go back a little bit into integers, different signs. I'm going to go ahead and subtract. And my answer is going to be positive because the absolute value of 6 is 6, and 6 is greater than -2. And then you have 5 minus 3, which is 2. And I'm going to go ahead and put plus 2 because that 2 is going to be positive. And this is your final answer. 4m plus 2 is your final answer. So here we go. We have to identify in these problems, we're going to have to identify our terms, how many terms we have, our like terms, coefficients, and constants. So for example 1, we're looking at negative 4y is a term. That's 1, comma. Negative 3 is my second term. And plus 2y, or just 2y, is my third term. So there's a total of 3 terms here. For example 2, I have 4 terms. Negative 5g is 1. 3, that's my second term. 2g and negative g. So that's 4 terms. Last one, we're looking at 5, 1 term. 3a, second term. Negative 4. And the last one, negative a. Now we're going to be looking at our like terms. Which terms are alike? So for number 1, our terms that are alike are negative 4y and 2y because they carry the same variable. Now, negative 3 is also a like term, but it's by itself, so you cannot combine that with anything. So I'm just going to go ahead and leave that one by itself. For number 2, we can combine negative 5g, 2g, and minus g. So those are all like terms. So negative 5g is alike. Again, they carry the same variables. 2g is a like term. And negative g is a like term. All these are like terms. And I'm going to go ahead and just leave 3 by itself because that cannot be combined with anything. It is not. If I had another constant, then I can say those two are alike, but I don't. So 3 is by itself. Last one, like terms, we have 3a, negative a, and that's it. So these are alike, like terms. And then we also have 5. These are constants, and we can combine these two since they don't carry a variable. And these two belong together. Coefficients, numbers in front of the variables. So for number 1, we have negative 4. It's a coefficient and just 2. That's it. For number 2, we have negative 5 is a coefficient. 2 is a coefficient. And negative 1, which is in front of that g, since it's negative. Its coefficient is negative 1. Number 3, coefficient is 3 in front of that variable a. And over here we have negative 1. And the last one, my constants. Constants, negative 3. Numbers by themselves with no variables. Constants here, positive 3. and constants, and number 3 would be 5 and -4. And we're done. Once again, practicing the parts of an expression. Last couple of exercises. We're going to go ahead and move down to now simplifying, combining like terms. So 3D plus 6D, 9D, just add them together. That's your final answer. Over here, we could combine 2 minus 4. That's going to give me -2. Different signs you subtract. You keep a negative since 4 is greater. Absolute value of -4 is 4 once again. Plus 5s. Can't do anything with this one. Last one, 2z can be combined with -9z. And then we're just going to go ahead and combine our +3 here. +3 with our -8. So let's do 2z minus 9z. That's going to give you -7z. That's a 7 there. And 3 minus 8 minus 5, or -5. Different signs, you subtract, you keep a negative. And that is our final answer. I hope that you guys are a little bit more clear with combining like terms and parts of an expression. See you soon. Bye.